Welcome to SAP Deployment Automation Framework. SAP Automation. Why? With the SAP Deployment Automation Framework, we look to lower costs, provide infrastructure as code supported by Microsoft, achieve faster time to delivery through effortless infrastructure deployments, achieve consistency in deployments, control drift through state management, have a DevOps approach which can help achieve better governance, provide scalable deployments. Vision statement: to deploy a standardized reference architecture using modular and independent steps that together result in a platform infrastructure that runs the SAP application and is ready to support several modalities. Ready to run, new implementation, bring your own backup, lift and shift as well as system refresh or system copy, DMO target, migration ready. Challenge approach. Supporting SAP deployments presents many challenges. SAP estates are complex environments with a variety of considerations. There is the non-prod separation, and regional versus global deployments. We look to solve the problem by addressing it as discrete building blocks. Terraform for infrastructure, as infrastructure as code. Ansible for server configuration, which is configuration as code. We are very happy to have SUSE join us as a development contributor on this journey to bring automation to the SAP workload. SAP on Azure Deployment Automation Framework. This diagram represents a simple deployment, representing a single region with two subscriptions. One subscription being the hub for the deployer and the SAP library. This can be considered a management zone, and a single subscription or spoke for the SAP workload. The deployment environment. Step 1. Clone the GitHub repository into the user's execution environment. Step 2. Create the deployment environment. Step 3. Store the SPN credentials for future deployments in the Azure Key Vault. Step 4. Instantiate the SAP library. The SAP library is the repository for software install. Step 5. From the deployer, instantiate the SAP workload zone. The SAP workload zone can be in the same subscription or it can be in a separate subscription. A workload zone is a VNet and common infrastructure to the SAP SIDs that are deployed into the workload zone. Deploying the SAP infrastructure. From the deployer, we deploy the SAP SID infrastructure. The SAP SID infrastructure consists of the SAP Central Services, the SAP Application Layer, and the SAP Database Layer. The SAP Central Services has a load balancer in front of it, as does the SAP Database Layer. The SAP Application Layer consists of one or more application servers, the first being the primary application server. The SAP SID deployment can also happen into a multi-zone deployment pattern. Some regions will support this, but there are latency requirements when dealing with HANA. In the multi-zone deployment pattern, one SCS server will be deployed into Zone 1 and one SCS server will be deployed into Zone 2. Same thing for the database layer. This applies to high availability environments. The application tier will be spread across both zones. Once a deployer and workload environment have been established, the repetitive unit of deploying an SAP system typically takes about 15 minutes for the infrastructure to be successfully deployed. Multiple deployments are possible to happen in parallel. Deploying SAP. Config. After the infrastructure has finished deploying, we can step into the second part of the deployment, which is the Ansible configuration as code deployment. From the deployer, we execute Ansible playbooks. There are multiple Ansible playbooks. They are broken down into several different sections. There's the OS section, which handles OS common tasks as found in the CIS guidelines. SAP specific OS tasks, which may include the application of SAP notes, logical volume management, volume creation, and file system mounting. Then there is the bill of materials, which handles the download of the SAP software for a given SAP product. We move down into the actual install of the software, which includes the database install, the SCS install, the database load, and the primary application server install. Subsequently, there will also be the application instance installs. Ansible playbooks, when they are run, will connect to the target servers via SSH. At the successful completion of the run of the Ansible playbooks, it will be possible to log on to the SAP system using the SAP GUI, or via SSHing into the box, we can run basis administration tools such as dpmon to observe the system is up and running. Summary. If we go and look in the Azure portal, we can see that we have resource groups that have been created. In this instance, we have a naming convention of NP, meaning non-prod, EUS2, meaning region East US2, and we can see that we have DEP01 and SAP01, both for infrastructure. DEP01 represents the deployer. SAP01 represents the workload zone. At the bottom, we can also see SAP library. That represents the SAP library. We see two additional resource groups, X00 and X01. From this naming convention, we can see that both are deployed in the SAP01 workload zone, and X00 and X01 represent two separate SAP system IDs. If we drill down into the SAP system ID, we will see that quite a number of resources for a SID have been created. In this case, we can see that there are 50 different resource types that are in this resource group, all of them as part of a single SAP deployment. There are going to be VMs, load balancers, availability sets, proximity placement groups, NSGs, and any other collateral resources that are needed. Furthermore, going back and looking at the resource groups, we can see that a workload zone can be representative of an environment. NP for non-prod, or prod for prod, followed by a region. You can have multiple workload zones. You could have non-prod in both East US2 and West US2, or you could have non-prod in East US2 and prod in West Europe, for example. To wrap things up, we strive to deploy consistent infrastructure following a reference architecture using Terraform for infrastructure as code, and provide server configuration using Ansible for configuration as code. We achieved the install of the SAP product using a bill of materials. This provides a framework for installing more than just a single SAP product. Our goal? Provide a repeatable deployment that will be able to achieve the same target over time. The SAP on Azure Deployment Automation Framework can be found on GitHub under the repo Azure/SAP-HANA. This repository is Microsoft supported infrastructure as code, and tested through Azure DevOps pipelines, to bring modular building blocks and an agile approach to drive collaboration, feature requests, empower customers and partners, drive adoption, and mature towards a feature-rich lifecycle offering.